Okay. Here we go for increasing and decreasing functions. Okay. What in the heck does this graph look like?
I don't know. Let's graph it and find out.
We could. I mean, we could go like this, plug in a 0, we get 0. Plug in a 1, we get 1 minus 2 is negative 1. Plug in a 2, and I don't know what we get. That'd be kind of hard. I mean, we could throw it in graphing calculator. Okay. 0 at 2? Okay, sounds good to me. What happens is it forms some, and I don't know where everything happens, but it forms a W. Why does it form a W? No. Okay. X to the first makes a straight line. X squared makes a parabola. X to the third is that. X to the fourth is a W. X to the fifth would be like this. It is something you should have learned before calculus. Yeah. Yep. It's the number of turns you take and so on. Okay. All right. If it's positive, it will end up. If it's negative, it'll end down. So negative for x squared is that. Negative for x cubed is that. Negative for x fourth is the m, and so on. Okay. We want to find out where things are increasing or decreasing. Instead of actually graphing them out, we can use a little calculus to figure it out. Okay? Using a little calculus, let's take the first derivative of it. What's the first derivative? Then let's find the critical numbers. How do we find critical numbers? Set the first derivative equal to 0. Factor out the greatest common factor. 2x squared, and we get 2x minus 6, right? The 3. Come on, Mr. Bierschbach. Do some math here. Okay, so we know x equals 0, and x equals 3/2. Okay? So at 3/2, we're going to have something, in this case a minimum. And at 0, what we're going to have is what's called a double root. So the graph will bounce at 0. So it must go like this, and then like this, and then like this. Or actually, I think it just stays flat and then goes down and then it goes up. That's what it does. Okay. How do we know that? Okay. Critical numbers are where we change from a negative slope to a positive slope, or from a positive to a negative, unless it's a double root. Then it doesn't change. Okay. So, because it stays the same, it goes from decreasing and then it kind of flattens out and then continues to decrease after that. It flattens out until 3/2, 1.5, and then after 3/2 it increases. So what's happening is it's decreasing the whole time. But as Ms. Strum said, how do we know that? Well, we look at our critical numbers on a number line. Our critical numbers are at 0 and 1.5, right? Okay. So what's a number in between 0 and 1.5 that's easy to work with? 1. So let's look at 1. Let's put 1 into the first derivative right here. We put in 1 in there, we get a -2. A negative number though. Our slope is -2, right? So if we know our slope is negative there, it's decreasing. What's a number on the other side of 0 that's an easy number? -1. If we put -1 in here, we get a -4 minus 6, which is a -10. Our slope is a negative number, so we know it's decreasing here. It's still decreasing. What's a nice number after 1.5? 2. So if we stick in a 2, we get 2 cubed is 8 times 4 is 32 minus 24 is a positive 8. The slope is positive. Okay? So these are where it changes. So the answer is it's only increasing from 3/2 to infinity. And then you're going, wow, that was a lot of work. Well, I was explaining it while we were doing it. So it won't be quite so much work when you do it. So let's look at the next one. And let's see what this one is. Okay, they already give us the first derivative. Okay, where are the critical numbers at? If we set this equal to 0, multiply both sides by x plus 3 squared, x minus 2 equals 0. So the critical number is that x equals 2. The critical number is that x equals 2. Now, we also know that the function is defined for all real numbers except for -3. What happens at -3? We divide by 0, so there's a big fat asymptote there. Okay? So there's an asymptote there at x equals -3, and at x equals 2 is a critical number. So we got to go in between them and figure out what's going on. What's a good number in between 0 or -3 and 2? 0. There we go. Thank you. If we do that, we get a -2 on the top. We get a 9 on the bottom. It's a negative slope here between these two. Okay, slope is negative. On the other side of -3, what's a number we want to work with? -4. -4 minus 2 is -6. -4 plus 3 is -1, but -1 squared is +1. So it's a negative over positive. It's a negative slope here. Okay, so we got a negative slope, negative slope. After a critical number, let's try like 3. We get positive over positive, which is a positive. So where is it decreasing? Well, it's decreasing from -infinity up until -3. Because there's an asymptote, we take a break there because there's no line there, so we can't say it's decreasing. In union with from -3 up to 2, it's decreasing, and then at 2, it changes and it starts increasing. And you're going, well, Mr. Bierschbach, that just doesn't make so much sense for me. Well, I can't do it for this one, sorry. But I was going to put in the original function, but we aren't given the original function. I would put in the original function into Desmos, and you could see how that works. But we could do that for a later problem, maybe. Okay. How many points are a relative minimum here out of these points? Now, this is the first derivative. So we don't know what the graph looks like, but we know these are the first derivative. So what do you do with the first derivative? Set it equals 0. How many critical numbers do I have? 3 of them. I have -2, -1, and a +3. Which ones will be minimums? Well, what we do to figure out if it's a minimum or maximum, we test numbers around them. So let's test the number in between -1 and 3. What's the number in between -1 and 3? 0. If we put a 0 in here, we get 2 times 1 times -3, which is a -6 or whatever. Yep, it's a negative number. Let's take a number in between -1 and -2, which is -1.5. -1.5 makes this a +1/2, a -0.5, and a -4.5. A positive times a negative is a positive. On the other side of -2, with like -10, makes a negative times a negative times a negative, which is a negative. On the other side of 3, let's take 10. A positive times a positive times a positive is a positive. So what's happening in the graph? Well, it has a negative slope, then a positive slope. There. From a positive slope to a negative slope there. From a negative slope to a positive slope there. Which of these are minimums? -2 and a +3. So there are 2 relative minimums. Okay, see how that works?
Yeah.
Okay, you gotta have just a general understanding of the graphs. All right, so here, now it wants to know where the relative minimums occur. Okay, well, this is a regular function, right? So if we have the regular function, we need to find the first derivative. Ooh, this is going to suck. Why is it going to suck? Because we have to do the chain rule and the product rule. Okay, so let's find the first derivative. So first derivative of this is -x plus 1 times the first derivative of that bad boy, which is 2 times x minus 1 to the first times the first derivative of the inside, which is 1, plus x minus 1 quantity squared times -1. Ew. So this, you know what? It might be easier to do. I don't know what the easiest way to do this is. Let's just multiply this whole stuff together. What's x plus 1 times x minus 1? X squared minus 1 plus, and then x minus 1 squared is x squared minus 2x plus 1 times the -1, right? And if we do the math, we get -2x squared plus 2 minus x squared plus 2x minus 1 if we distribute the numbers through there and add. So we get -3x squared plus 2x plus 1. Okay. So set the first derivative equals 0. Let's factor this bad boy. 3x and -x. Plus and 1 and 1, right? So we get -3x squared. Outers is plus 3x. Inners is minus 1x, which makes 2x times last. So x equals what here? -1/3, and x equals what here? No, +1, because it's taking a 1 makes it 0. All right, so those are the 2 critical numbers. Okay, a little bit of work to find those critical numbers. So we got to figure out now which one is the minimum. Yeah, you just graph the original function on your graphing calculator and you can find it really quick, right? Yeah, you can. But I'm showing you the right way of doing this. All right, -1/3, +1, because this might be a section where you can't use your calculator on the test. That's on the AP test. So if we check out 0 into the first derivative here, we get a positive number times a positive number, so it's positive right here. So if we check out a 3, we get a positive times a negative, which is a negative. If we check out a -10, we get a negative times a positive, which is a negative. So it's going from a negative slope to a positive slope here, and from a positive slope to a negative slope here. Relative minimum happens here at -1/3. Okay, a little bit of work to some of these. Okay, where's the relative minimum here? What should we do first? First derivative. And so it's -3x squared plus 6x, set it equal to 0, factor out a -3x, and you get x minus 2 equals 0. So x equals 0, x equals 2 are your 2 points. So if we check a 1 into here, we get a negative times a negative, which is a positive. If we check a 3 in here, we get a negative times a positive, which is a negative. We get a negative, so it goes like this, and it goes like this. Where is the relative maximum? 2. And that's what you got on your calculator, right? Mm-hmm. Just by looking at it. Okay? Okay, the next thing is over a closed interval, finding a maximum or minimum. Okay? We do the same thing, but then we have to check the endpoints because it's over a specific interval. Because if the endpoint says a higher number than the critical number maximum, then it would be the maximum. Okay, I'll show you how it works. Okay, so let's do the normal first. Okay, so it's the first derivative, which is so if we factor out a negative 6, we get x squared plus x, x squared minus x minus 6, right? So it's x minus 3, x plus 2. So our critical numbers are 3 and negative 2. So our check numbers in the interval are at negative 3, negative 2, 5, 3, and 5. And so what we're going to do, it wants the absolute maximum value, not the value of x, which gives it a maximum. It wants a maximum value. So we take each one of these and stick them into the original equation. Okay? So if we stick negative 3 in here, use your calculator and figure out, what the maximum value is. Okay? And then 2, and then 3, and then 5. And actually it wants what x value works for these out of those 4 x values. But you have to stick them into the original to figure out what is the highest number. So if you stick negative 3 in here, you get negative 27. If you stick negative 2 in there, you stick negative or positive 3 in there,
You get 81.
and if you stick 5 in there, I bet it's a number smaller than 81.
5.
Okay, where does the relative maximum occur? The relative maximum occurs at 3. What is the relative maximum? The relative maximum is 81. Okay, it's not always going to occur in between them. Sometimes it'll be an endpoint.
Is 3 the value?
3 is the x value where the maximum occurs. 81 is the maximum value, which you really got to watch the wording, because if you don't, you'll get one wrong and then you'll be really ticked off because you just didn't look at the wording. This one is the same type of thing, finding the x value. Okay, do we need to do this one or should we skip it? Okay, so you got that. Okay, here's what is the maximum value of h. Let's look at this one. Okay, so this is over, does it have a set of numbers that you're finding? No. So this is over the, from negative infinity to infinity, what is the maximum value? Okay, what's the maximum value? So take the first derivative, set equals 0, factor out 4x, and you get x squared minus 1. How does x squared minus 1 factor? And look at 0, negative 1, and 1. Geez, these 3 numbers. Imagine that. You got to check those. Okay? So by checking them, we can put them into the actual problem. If we put in a -1, we get 1 minus 2, which is -1. If we put in 0, we get 0. If we put in 1, we should get the same as the first answer. 1 minus 2, which is -1. Okay? What's the maximum value of that function? Or what's actually happening here? Well, it's going to be a W function, right? Because it goes at -1, its value is -1. At 0, its value is 0. At -1, it's -1. And then after that, it's going to turn around and go positive again. So, is 0 going to be the maximum value over the entire function? No. It has no maximum value because it's going to go on for infinity, both places. Now, if it asks for the minimum value, what would the minimum value of this function been? -1. Okay? Because they both have a minimum value of -1 there. Okay? Ooh, natural log. Dang it. Dang it. We can't just use your calculator. We actually have to do a little calculus here. Yeah. You could have a pretty good idea, but I bet the calculator won't tell you the right answer. Okay. So, how do we find the first derivative of this bad boy?
The quotient rule.
Thank you for saying that. Quotient rule. X squared times what's the first derivative of the natural log of x? 1 over x. Minus the ln of x times the first derivative of that, which is 2x over the bottom squared, x to the fourth. Well, x times 1 over x is just x minus 2x ln of x over x to the fourth. Well, you can factor an x out, so it's 1 minus 2 ln of x over x to the third. So that equals 0. What happens? So 1 minus 2 ln of x equals 0. Move the 1 over. -2 ln of x equals -1. Divide by -2. Where is the ln of x equal to 1/2 at? How do you figure that out? Well, you just e both sides. So e to the 1/2 power. E cancels out natural logs. Remember that from Algebra 2? You're supposed to remember that. E and natural logs are inverse functions. So e cancels out natural logs, so you have e to the 1/2 power. That's the critical number, okay? So if we put that critical number into the original function, because we only have one critical number, so it's either a max or a min. If you graph this, what does it look like? Kind of looks like that, right? Okay. But this actually is going down again, if you can believe it or not. So the maximum value occurs here. What is the maximum value? Well, if we stick it in there, the ln of e to the 1/2 over e to the 1/2 squared. What's e to the 1/2 squared? E. What's ln of e to the 1/2? 1/2. 1/2 over e is the same as 1 over 2e. Okay? Let's do one more with an e in it because, yeah, your e skills might not be exactly great. All right. So how do you find the first derivative of this? Product rule. X cubed times e to the x plus e to the x times 3x squared. So you actually factor out e to the x times x squared, and you get x plus 3. So x equals 0 and x equals -3. Okay? Well, this time, just because we have 0 squared, it's a double root, I want to do this way. So let's check our numbers into the first derivative. So let's put a 1 into this first derivative. E to the 1 is 2.718281828459045, right? And 1 squared is 1. 1 plus 3 is 4. It's going to be a positive number. So we're positive here. What about in between here? Let's put a negative 1 in here. E to the negative first power is 1 over e. 1 over a positive number is still a positive number. Negative 1 squared is a positive number. Negative 1 plus 3 is a positive number. A positive times positive times positive is a positive. On the other side of negative 3, what? Because I'm putting it in this one right here.
Why? Like where?
Because it's easier.
Okay.
Negative 1 squared makes a positive, and negative 1 plus 3 is an easy number too. And so it's easier than putting it up there. If we put in a negative 4, e to the negative fourth is 1 over e to the fourth, which is still a positive number. Negative 4 to the second power is a positive number, but that makes this a negative. So when it's going down and then it's going up and after that going up, this will be where the minimum occurs at negative 3, right? So what is the absolute minimum? Well, you stick negative 3 into here. It's negative 3 cubed e to the negative third. So it's negative 27 over e to the third, which is choice B. All right, so you have some work cut out for you today. Now, and Friday, because this is today and Friday both.
Oh, you're already done with both?
Yeah.
Oh, let's go.
And there's a